Hey everyone, where's the math in this problem? Let's say we are given this geometric figure. The height of this small square here at the corner is 4 units. This red shaded region is formed from quarter circles. And this is how we draw this figure. We are going to use 4 quarter circles, and this is the first, then here is the second, and here is the third, and here is the fourth, and finally we have the figure that we want. Then we are going to shade this region red and the background is white. Our goal is to find what is the area of this region that is shaded red. You can pause the video and see if you can solve this beautiful geometry problem. Now let's solve this problem together. One way of attacking this problem is if we cannot directly solve for the area of the red shaded region, we can indirectly solve for its area by first finding the area of the enclosing square and then subtract the area of the region that is shaded white. The difference would be the area of the red shaded region. So let's find the area of the white space here. We know that this is a 4x4 square, and therefore its area is 16 square units. The same with this neighboring square. Then to find the area of this part here, we can consider first this square, and then we can subtract this quarter circle at the bottom. The resulting area would be the area of this region that is color white. Now, what is the dimension of this square? We know that that is 8 units, and similarly, the radius of our quarter circle is also 8 units. So to find out the area of this white space, we subtract the area of the square, which is 64 square units, minus the area of this red quarter circle, which is 1/4 the area of a circle with a radius of 8 units. Simplifying, that becomes 1/4 times 64 pi, and 1/4 of 64 is 16. We copy all the rest. This is now the area of this white region here. Then let's find the area of the white region here at the bottom. So in that case, we need to look at this big square and subtract the area of this big quarter circle at the upper left-hand corner. So when you get the area of the square and subtract this red quarter circle, the resulting area would be the area of this white space here. So how do we compute that? The dimension of the square here is 12 by 12, and therefore its area is 12 square. Then the area of this red quarter circle is 1/4 the area of a circle with a radius of 12 units. Simplifying, we have 144 minus 36 pi for the area of this white space here. Let's remember that result. Next, we still do not know this white space here and this area inside this cavity. What we can do is we can draw a line segment connecting this point to the corner. And you can now think of this as composed of 3 regions. We have this triangle here, we have this region here that is a segment of a circle, and we also have this region which is also another segment of a circle. So let's find the area of this right triangle, that is 1/2 base times height, where the base and the height are both 4 units, and that gives us an area of 8 square units for that space. Then for this segment of a circle, we can first consider this quarter circle and subtract the area of this triangle. That will give us this segment of a circle. And for its area, we subtract the area of this yellow quarter circle minus the area of this right triangle. So area of this yellow quarter circle is 1/4 the area of a circle with a radius of 4 units, and that is pi r squared, and get 1/4 of that, minus the area of this right triangle given by the formula 1/2 base times height. The base is 4 and the height is also 4. And simplifying, this gives us a value of 4 pi minus 8. Let's remember that area. And finally, we still have one region here that we need to find the area of. And that is composed of this quarter circle minus this right triangle. And to find its area, the area of the quarter circle is 1/4 pi 8 squared, because the radius of this quarter circle is 8 units. And the area of this right triangle is 1/2 base times height, where the base and the height are both 8 units. And simplifying, this gives us 16 pi minus 32. And let's remember that result. So we now know the area of each of these regions that is colored white. And if we add the area of this red shaded region to the areas of those regions that are colored white, then we get the total area of the square. So let's call now the area of this red shaded region as x. If we get all the sum of the areas inside the square, here is the result. And the sum of all of this must be equal to the area of the square with a side of 12 units, which is 12 squared. So finding now the sum of all of these terms, let's rearrange so that we have all the constants in this column, we have all the terms with pi in this column, and we have the variable x alone in the left column. So adding all of these terms, we have x plus 208 minus 32 pi, and that is equal to 12 squared or 144. And from here, we can now solve for x, which is the area of our red shaded region. Subtracting 208 from both sides of the equation, we get x minus 32 equals 144 minus 208, which is negative 64. And then solving now for x, we add 32 pi to both sides of the equation to get x equals 32 pi minus 64 square units. This is now the value of x, which is the area of the red shaded region. And that is approximately equal to 36.53 square units, which is now our final answer. And that is where the math is. Thank you very much, and we hope to see you again in our next video. Bye for now.